Okay, so let's continue. We can ask, are addition and multiplication of rational numbers fine? Are addition and multiplication of rational numbers, I'll just say rationals, are addition multiplication of rationals well defined? So, for example, consider rationals R1 and R2. So, how can we define R1 plus R2? So, here is the process. Pick representations R1 equals m by n. So, you represent R1 as m by n, where mn are integers, n is not equal to 0, and write R2 as p by q, where p, q are integers, q not equal to 0. So you pick representations of this form, then compute uh, qm plus np by nq, and then define r1 plus r2 to be qm plus np by nq. This is the definition. So we pick two representations of the two rational numbers, compute certain quantity in terms of the representations, and define the sum of the rationals as this quantity. So in the above process, is R1 plus R2 independent of the representations we pick? In the above process, is R1 plus R2 independent of the representations of R1, R2 we pick? So in this step, we use this step, right? Pick representations m by n and p by q. So we could have picked any representation. In the above process, is the end result R1 plus R2 independent of the representations m by n and p by q we pick? So let's see that. Observation. Addition of rationals is well defined. So what is the process? The process is simple. Consider rationals R1 and R2. We want to add R1 and R2. What we do is we pick two representations. We pick representations of R1, R2 in terms of m by n and p by q, and then compute this quantity qm plus np by nq and define this quantity to be R1 plus R2. But notice that this quantity, we can say this quantity depends on the representations we chose, or let me not confuse or yeah, so this is the process for adding. We say this is the process for adding two rationals R1 and R2. Pick representations, compute this quantity in terms of representations, and set R1 plus R2 as this quantity. Now for this to be a valid definition, we need this quantity which we set as R1 plus R2 to be independent of the representations of R1 and R2 we pick. So in the above process, Is R1 plus R2 independent of the representations of R1, R2 we pick? So the observation is addition is well defined. Addition of rationals is well defined. Let R1, R2 be rationals. Pick representations. So suppose you have two representations of R1 and two representations of R2. P by Q equals P dash by Q dash. Pick representations R1, R2 of R1, R2. Then this quantity Qm plus Np by Nq is the same if we compute for M by N and P by Q, or if we compute for M dash by N dash and P dash by Q dash. Dash by N dash Q dash. Hence, the above process of computing R1 plus R2 is independent of the representations of R1, R2 we pick. Or I'll write. So the above process is independent of the representations of R1, R2 we pick. So we'll show this result. So proof of this result is we have two representations M by N and M dash by N dash of R1. Similarly, we have two representations P by Q and P dash by Q dash of R2. We are to show that. So to show is this quantity is same. Qm plus Np by Nq equals Q dash M dash plus N dash P dash by N dash Q dash. So we are to show this. Note that so Qm plus Np times N dash Q dash is Qm N dash Q dash plus Np N dash Q dash. Now M and N dash, this is equal to, because M by N and P by Q are equal, M N dash is M dash N. So we can write this as M dash N Q dash plus, and again PQ dash, this quantity, this is equal to PQ dash is equal to QP dash, because P by Q and P dash by Q dash are equal. They are both two representations of R2. So PQ dash is QP dash. So this is QP dash. So because Mn dash is M dash N and PQ dash is QP dash, right? So P by Q is P dash by Q dash, M by N is M dash by N dash. Hence we can replace, hence we have this equation, and here we can write, now we can take NQ common, then we'll get NQ times M dash Q dash plus N dash P dash. Hence we found that Qm plus Np, I'll write Q dash M dash here just to be consistent. So hence Qm plus Np by Nq equals Q dash M dash plus N dash P dash by N dash Q dash as needed. So we found that this quantity is the same, Qm plus Np by Nq. So computed with respect to the representations M by N and P by Q, and the result computed with respect to representations M dash by N dash and P dash by Q dash, both the results are equal. We found this. Hence the above process of computing R1 plus R2 is independent of the representations of R1, R2 we pick. So we can do the same thing for multiplication. So how did we begin? So consider rationals. So consider rationals R1, R2. So we have the question, how can we define R1 times R2? So we follow the procedure, pick representations, R1 equals m by n, mn are integers, n is not equal to 0, and pick representations of R1 and R2. After you pick the representations, compute in terms of the representations this quantity mp by nq. Then you define R1 times R2 to be. So this is the procedure to compute the product of two rationals. Now we can ask, so like the same question we asked above, in the above process is R1 plus R2 independent? So here we'll ask, in the above process is R1 times R2 independent is R1 plus R2 independent of the representations of R1 or the representations of R1 R2 we pick. So this is the question. Only then is the above definition well defined. This process should be independent of the representations. This independent of the first step, the way we perform the first step. It should be independent of the representations we pick, because we are defining the product of R1 and R2, not product of the representations, so to speak. So in the above process is R1 times R2 independent of the representations of R1, R2 we pick. So observation. This is multiplication of rationals is well defined. Let R1, R2 be rationals. Now pick representations. So pick representations R1 equals m by n equals m dash by n dash. R2 equals p by q equals p dash by q dash of R1, R2. Then we have mp by nq. The product computed with respect to representations m by n and p by q is equal to m dash p dash by n dash q dash. Hence, the above process of computing R1 times R2 is independent of the representations of R1, R2 we pick. Right. So here's the proof. We are to show, we are given two representations m by n and m dash by n dash of R1. We are given two representations p by q and p dash by q dash of R2. We are to show, so mp by nq equals m dash m dash p dash by n dash q dash. So note that mp times n dash q dash is, so here we have information about mn dash. Mn dash is same as nm dash, and we have information about p by q, so we can merge these two together. So mn dash is nm dash and pq dash is p dash q. So this is because mn dash is m dash n, or nm dash here because I wrote nm dash. And it's better to write m dash n, I guess. This is more natural, changing mn dash to m dash n, so we're preserving the order of mn n, so to speak. So because mn dash is m dash n and pq dash is p dash q, because m by n is m dash by n dash and p by q is p dash by q dash. We have these two equations, and hence we wrote mp times n dash q dash as m dash n times p dash q. So we can then write this as nq times m dash p dash. Hence, so we got mp times n dash q dash equals nq times m dash p dash. That is mp by nq equals m dash p dash by n dash q dash. So this is, we got the inequality, we got the equality as needed. Hence, the above process of computing R1 times R2 is independent of the representations of R1, R2 we pick, and multiplication of rationals is well defined. Hence, finally, we saw that addition and multiplication of rationals is well defined. So the first question we asked, is addition and multiplication of rationals well defined? So it is true, and we checked it. Right. So that's all for this part. See you in the next part.